Hi everybody, welcome to your introduction videos. So this week we're going to do simultaneous equations, which I have already done. So this is pretty much all revision work, okay? But very important topic you can't really afford to get wrong, okay? We're going to learn two methods for doing simultaneous equations. One is called elimination and the other is called substitution. Okay, so I'm going to look at a couple of examples from here first, just to remind you of what's going on. Okay, so I'm just going to look at the first one. Is going to be x plus 3y equals 26, and x minus 3y equals minus 22. This is a good one to start us off. So we've got two equations here. What I need to do is find out the value of x and the value of y. Okay? Now the process is called elimination. Elimination. Now elimination, another way of saying it, and the meaning of elimination is to kill, to destroy, to disappear. Okay? So we're trying to eliminate one of the variables. Okay? And what I can do is, way I can eliminate that, if I do equation 2 minus equation 1, or the other way around. In fact, I'm going to do it the other way around. I'm going to do equation 1 minus equation 2. And so all I do is I pair things off, and I say, what's x minus x? Well, x minus x is nothing. That is brilliant. That means I have eliminated the x. Now we've got to do 3y minus 3y, and that be really careful with that. It's so easy to get it wrong. Okay, and to say that 3y minus 3y is 0 as well. It's not, because I'm saying equation 1 minus equation 2. So 3y minus 3y is positive 6y. And then 26 minus 22 is 26 plus 22 is 48. And so now I've got an equation where there is no x, so it's possible to find y. So y is simply going to be 8. 48 divided by 6 is 8. Okay? Right, now I've found out y, don't forget that you can find out what the value of x is as well. By choosing an equation and substituting what we now know the value of y to be. So look at equation 1. So I'm going to sub into equation 1. It's going to be x plus 3 times 8 equals 26. So x plus 24 equals 26. Therefore, x equals 2. And there are my solutions. Y is equal to 8 and x is equal to 2. Now, just for the record, obviously what we could do is we could plot both these lines on a graph. Okay, and what would happen is, without a doubt, they would intersect at the point 2, 8. So another method actually of solving simultaneous equations is to plot them on a graph and look for the points of intersection. Okay, so I hope that is clear. Let me just get rid of these. Okay, let's just do one more example. Let's just check the answer actually. Here we go, I was right. Okay, let's go for D. So that's 3x plus 2y equals 8. And 2x plus 2y equals 7. Okay, so we've got equation 1 and equation 2. Again, I can eliminate the y's by subtracting. This time I eliminate the y. So 1 minus 2, okay, will mean 3x minus 2x is 1x. 2y minus 2y is nothing. It's eliminated. And the answer is 1 because 8 minus 7 is 1. Okay, now I know what x is. Sub into equation 1 or equation 2, it doesn't matter. So we can say 3 times 1 is 3 plus 2y equals 8. And so now 2y is equal to 5. Subtract 3 from both sides. So y is equal to 5 over 2. And I'm happy for you to leave that as a fraction, or you can say y is equal to 2.5 or 2.5, something that is equivalent. Okay? So remember, the value of x and the value of y may not be a nice integer number. It might be a fraction, or it might even be a negative or even a negative fraction. Okay, so just be aware of that. But you can always check your answers. Okay, we can always check our answers by substituting our answers back into the equations. So let's just substitute our answers into equation 2. 2 times 1 plus 2 times 2.5 equals 7, hopefully. Well, 2 times 1 is 2, plus 2 times 2.5 is 5, and that equals to 7. So a little check tells me that I have got the right answer. Okay, so the good thing about simultaneous equations, and any equation in fact, it's always easy to know if you got it right. So if you did something stupid, like, what, for example, remember when we said 3y minus 3y, you got that situation wrong, you should know you got it wrong because you check, because you're not lazy. Okay, it's so important that you check your answers all the time. Okay, now, these ones are just slightly different. Okay, let me just get up a blank page. Okay, and let's write one down. So we've got 2x plus 3y equals 17, and x plus 2y equals 10. Now let's call this equation 1 and this equation 2. This time there's nothing I can do at the current time to eliminate, because if I do equation 1 minus equation 2, I will end up with 2x minus x is x, 3y minus 2y is y, and 17 minus 10 is 7. I have failed to eliminate anything. So my process has not worked there. But I can make it work by doing something first, and that is by timesing equation 2 by 2. If I do that, I'm going to call it equation 3. Then I will get, times everything in that equation by 2, I'm going to get 2x plus 4y equals 20. Okay? Now what I'm going to do is I'm going to do equation 3 minus equation 1. I could do 1 minus 3, but I want to avoid negatives. Okay? So I'm going to do 2x minus 2x is nothing. Now I've eliminated x's. 4y minus 3y is y. And 20 minus 17 is 3. So y is equal to 3. Now substitute into any of these equations. I'm going to choose equation 2 because it looks the easiest. So sub into 2. Then we're going to get x plus 2 times 3 is 6. And so x is equal to 4. There is my solution. When x is equal to 4, y is equal to 3. Okay? Let's delete that. Okay, let's go for a trickier one. Let's go for D. It says 3y equals 6 plus 11x, and 9x minus 5y plus 24 equals 0. Now the first thing you'll notice here, it doesn't follow the same format that we had it before, where we've got some amount of x, some amount of y, and then the number on the right hand side. So let's just change it so it does look like that. So we call this equation 1, this equation 2. Let's write equation 3. I'm going to write that as 3y minus 11x equals 6. And I'm going to write the second one, I'm going to call it equation 4. I'm going to write it as minus 5y because I want the same order. Something y, something x equals something. So minus 5y plus 9x equals negative 24. Now we've got negatives in here, so we're going to have to be really, really careful with that. And we're also not in a position where we're able to eliminate anything right now because, you know, minus 5y plus 3y, that's going to give me 2y, and 9x plus minus 11x will be minus. You're not eliminating anything this way, okay? So we need a little trick. What we're going to do is we're going to multiply equation 3 by 5 and equation 4 by 3. Because look what happens if we do. We're going to end up with equation 5, which is going to be 15y minus 55x equals 30. And equation 6 will be negative 15y plus 27x equals negative 3 times 24, 72. Okay, minus 72 rather. Okay, so I've got equation 5 and equation 6, and now I'm going to be able to eliminate y's, okay? But how? I'm not going to take them away because 15y minus 15y would give me 30y, and then I wouldn't have eliminated. What I'm going to do this time is I'm going to do 5 plus 6. And if I do that, I will get 15y plus negative 15y is nothing. Y is eliminated. Minus 55x plus 27x is minus 28x is equal to 30 minus 72. I think that's minus 42. Minus 42. So x equals negative 42 over negative 28. So that's going to be a positive. It's going to be a positive value. And now let's see if we can simplify that. I think that is equal to 3 over 2. 1.5. Okay. Now we've got to substitute the value of x back into one of the equations. Let's use the most simple one that I can. I think it's equation 1. Okay. We're trying to find y. So equation 1 says 3y equals 6 plus 11 times 3 over 2. There's a bit of fraction work here as well. 3y equals 6 plus 33 over 2. 3y equals common denominator 12 over 2 plus 33 over 2. 3y is equal to 45 over 2. Now we're going to divide both sides by 3, so y is equal to 45 over 2 divided by 3, which is the same as y equals 45 over 2 times 1 over 3, flipping easy rule. So that's 45 over 6, which I think we'll find is 7.5, 7.5, and that's 1.5. So x is equal to 1.5. Y is equal to 7.5. There is my answer. Okay, so that is how we do these simultaneous equations by elimination. And you can see they can get quite tricky. We've got to understand negative numbers. We've got to understand fractions. Okay, let's skip past this. Okay, here are some questions for you to do. Stop your video and have a go. Okay, hopefully you've done that. Here's the answers. Okay, some nice easy ones there. Okay, again, stop your video and have a go at these. Here's the answers. Some negatives in there. Okay, last set of 4 questions. Stop your video and have a go. Okay, here we go. Here's the answers. There we go. Okay. If there are any questions there that you got the wrong answer and you don't know why, just ask me. I'm more than happy to help you. Okay. I'm going to stop the video, and the next section is going to be on how to solve simultaneous equations by